Hi! Today we're going to do some examples with trapezoids. Here's the first one. We need to show that CDEF is a trapezoid. Now trapezoids have exactly one pair of parallel sides. So two sides that are parallel. And looking at this diagram, which we shouldn't trust much, but it kind of looks like this side here and this side here could potentially be parallel. And then they'd be the bases of our trapezoid. So if we find the slope of this side and the slope of this side, if those values match, then this would be a trapezoid because those sides would be parallel. So let's find this red slope first. We can use the slope formula, and we'll write the slope of DE. So the slope of line segment DE is equal to y2 minus y1. So the difference of the y coordinates over the difference of the x coordinates. And in this case, let's see, we have 4 minus 3. So 4 minus 3, that's 1. And we have an x coordinate of 4 minus 1. So that's 3. So the slope of this line is 1/3. We can also see it goes up 1 over 3. So that seems like we did it correctly. Let's find the slope of the green line segment. So here we say the slope of CF. We'll use our slope formula again. And in this case, let's see, 6 minus 0, or 2 minus 0 in the numerator, 6 minus 0 in the denominator. All right, since the slope of each of these line segments is the same, it means these lines are parallel. These line segments are parallel. That means this is in fact a trapezoid. So to finish this off, we should say DE is parallel to CF, and CDEF is a trapezoid. Let's look at another example. Example 2, we're actually told this is a trapezoid, and it's a special kind of trapezoid. It's called an isosceles trapezoid because the two legs are congruent. In an isosceles trapezoid, the base angles are also congruent. So if this is 50, this angle right here has to be 50 as well. All right. Well, in this problem, we're supposed to find the measurement of angle N, L, and M. So we just found N. We've got that. So the measurement of angle N is 50 degrees. Now we need to figure out these two angles. One thing we do know is we know they're congruent, because base angles and isosceles triangles are congruent. And what we also know is the sum of these four interior angles have to add up to 360, since this is a quadrilateral. So this unknown angle that's here and here, it's the same angle. Let's call that x. We don't know what x is. But what we do know is the sum of all those angles has to be 360. So we know that 50 plus 50, that's these two angles, plus the two unknown angles, has to add up to 360. If we do some algebra, we can figure out what the unknown angle L and unknown angle M is. Let's see. Just combining like terms there. Now we'll move the 100 to this side and divide everything by 2. So we just found x is 130 degrees. That means angle n is 50 degrees, and the other two angles we don't know are both 130 degrees. All right, one last example. In this example, we're given a trapezoid, and we're supposed to solve for x. One property of trapezoids is if you have the mid-segment, which is the segment that connects the midpoints of the two legs of a trapezoid, this is going to be the average of these two numbers. So to find an average, you take the numbers, add them all together, and divide by how many numbers you have. We have two sides. If we add these sides together and divide by 2, we'd find the average value. So right now we know the average between whatever these two side lengths is 20. Here's what we're doing. If you take base 1, here's base 1, and you add it to base 2, and cut that value in half, that will tell you the length of the mid-segment. We'll abbreviate that with MS. All right, so let's fill in these values and see what we get. 1/2 of base 1 plus, here's base 2, has to equal the 20, the mid-segment. If you multiply both sides by 2, we can get rid of that 1/2. Combine like terms. Move the 12 over. So the value that will make this trapezoid correct is 4. We'd put a 4 there. All right, that's it.